So the topic is going to be homologous series. This would probably show up in a lab-based question. If you're looking for a manipulated variable and you're doing a organic chem type lab, this would be the type of sequencing you'd want to think of. Okay? We're going back into properties and intermolecular forces. So maybe you want to study melting points of something. Okay? You'd probably pick a homologous series to change in your lab and see how the melting point changes within a homologous series. So what are they? Okay. A homologous series is a bunch of molecules in the same family, and the difference is just the carbon count. Each consecutive member has an extra carbon, and if you think of adding an extra carbon, when you add a carbon in a sequence, okay, my two blue dashes are meant to be dashes going to other carbons in a sequence, but you need to add two hydrogens to that carbon as you add it into a chain. So the CH2 unit is just coming from an additional carbon, requires an extra pair of H's in that chain. So we're going to name and draw the next members of the homologous series. And the first series, I'm going to start with propene. Now I'm going to draw this to give you a visual. You don't necessarily have to draw these if you can picture them in your head. Okay? So propene would be 3 carbons long, that's prop. And then there's no number, which means some number was dropped. Okay? And the reason for that is no matter where you put the double bond, it's going to be at an end or the 1 position. So that is why the number was dropped. You often have to add numbers in as the homologous series grows. So the next member keeps everything the same except is 1 carbon longer. So we have to keep the double bond in the 1 position. So the next member would go from prop to bute, would have to keep the double bond, and then we got to think, do we need the number? So let's get a visual for butene. There's bute. The double bond must be at the beginning. And now that double bond is in the 1 position, but could it be in the 2, the 3? It couldn't be in the 3 because that'd be the other extreme end. That would really be the 1. But the double bond, in theory, could be in the 2 position. So I need a number here to tell the reader it's at the very beginning. Okay. With propene, I didn't need the number. Of butene, I need the number. And as I continue this series, I'm just making the stem or the parent 1 longer. I'm going to stop drawing them now. What comes after bute? Prop, bute, pent. So that's 1 more carbon, and I got to keep that double bond in the 1 position. So anything that has a double bond in the 1 position with no other side groups will be a member of this series. So I'm going to go ... skip a bunch of members. Dec 1-ene would also be one of the members of this series. Dec 2-ene or 3-ene would not be. So we're keeping everything the same except the parent is growing. Okay? And that's what you do in a lab. You keep everything the same except for you vary 1 piece. You don't vary where the double bond is. You don't vary if there's a double bond. Okay. A second example, I've got a branch and an ane. And I got no number on that methyl. So I'm going to pause for a bit. I want you to think what number is missing. You may need to draw it. Okay? Or maybe you can picture it in your head or figure it out without drawing. Is that 1 methyl, 2 methyl, 3 methyl? What number did I not write on purpose? So I'm going to do a little bit of a sketch to guide us. Okay. You can do sort of non-proper drawings if it's just to guide you. So we've got 3 carbons. I'm not going to put in my H's to this sketch because I'm not trying to do a proper diagram. But I've got those 3 carbons, and where can I add the methyl? I can't add it at either end because it would become a pent, the longest chain. So I have to add it to the middle, and the middle carbons, this one would be the 2 position from the left. But if I added it to the other carbon in the middle, that would be the 2 position from the right. And I can't add at an end. So the number that wasn't written here that your brain would have to realize is this is a 2-methyl with the 2 dropped. So the next members of the homologous series, the parent will grow and the methyl will stay in the 2 position. So the next member is 2-methyl and not butane, but it'll be pentane. The next member still has to be 2-methyl. And after pent is prop-but-pent hex. And 2-methyl octane would also be a member of that homologous series, jumping ahead a few. Okay. So the methyl is a controlled variable, the ane is a controlled variable. It's just that parent or stem.